f of x is equals to k to the power of x, where k is supposed to be greater than 0. The point of 416 lies on the graph of f. So we are given this graph here, and the first question of 5.1 is to determine the value of k, right? So to determine this value of k here, we have f of x being equals to k to the power of x, right? So we're going to use this point here, which is point of 4 and 16, and this is x, this is y, so we're going to substitute in this equation here. So where there's y, you put 16 equals to k to the power of 4, right? And then you can just multiply with 1 over 4 both sides, 1 over 4 both sides, and you should get k being equals to 2. Okay, so we are done with this question here. Let's do 5.2, which says that graph G is obtained by reflecting graph f about the line y is equals to x. Determine the equation of G in the form of y is equals to. So this graph of G that the question talks about is reflected about this line of y is equals to x. Y is equals to x. So what's going to happen is this, the reflection is going to cause this coordinate here of 0 and 1 is going to be 1 and 0 here, right? And this coordinate here of 4 and 16 is going to be 16 and 14. So let me first draw the graph. So it's gonna look like this. So the graph of G is gonna look like this, and then here is going to be 16 and 4, right? So to write down the equation of this graph of G of x, we're gonna use the f of x being equals to k to the power of x, right? And we found k to be equals to 2 in the previous question. So f of x is equals to 2 to the power of x, which is y is equals to 2 to the power of x, right? So we're just gonna where there's x we put y, and where there's y we put x, right? So we're just gonna say x equals to 2 to the power of y, and then we use our logs by saying y is equals to log of base 2x. So this is going to be the equation of this g of x, which is going to be y is equals to log base 2x, right? So that's how we solve this problem here. So 5.3, we are asked to sketch the graph of G, indicating on your graph the coordinates of 2 points on the graph. So the graph is exactly the one that I just did, which is this one here, and it has this point here of 1 and 0, and this point here of 16 and 4. So this is the graph of G of x. And then 5.4, use your graph to determine the values of x, for which 5.4.1, when you multiply the y value of f of x with the y value of g of x, you're getting a solution which is greater than 0, which I wanted to say positive solution, right? So we want to look at a situation when that happens. So where does that happen? You go back to your graph. So this is f of x, right? F of x, and this is g of x, right? So where in this graph do you multiply the y value with another y value and getting a greater than 0 solution, right? So what we need to first look is because for you to get a greater than 0 solution, you have to, when you multiply a positive with a positive, you're going to get a positive, right? Or when you multiply a negative with a negative, you're going to get a positive, right? So you want to check where both y values are positive or where both y values are negative, right? So unfortunately in this case there is no situation like this one where both y values are negative, right? Why am I saying that? It's because here the graph of f doesn't have negative y values, right? So only the graph of G has negative y values. So this situation is out. So we're going to look at a situation where we have both positive y values. When you multiply them together, you're going to get a positive solution. So that applies because here it's positive, 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 right? Going up as positive. So everything is positive here. Positive. So what am I saying? I'm saying y values are positive here. Y values are positive, right? Because it's the y-axis, the positive y-axis. So even here, so here there are negative y values, negative, 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 negative y values, but here they start to be positive y values, positive, 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 positive y values, right? So we're going to start where y values start to be positive. So in this case, they start from this side going up, right? But we don't really care much about this portion of the graph because there is no g of x in this side. So we're going to start where g of x starts with positive y values, which is this point here. So this point here is where g of x has positive y values, and you start to so at this point here also, so even though here we have positive y values for the f of x, but there's no positive y value for g of x, it's only negative. So this positive multiplied by this negative here gives us a negative solution, so we don't want that. So but here we're having positive solutions of y, and when you multiply them with this positive solution of y, they give us a positive solution of y. You get what I mean? When you multiply these y values I'm talking about with these y values, you get a positive solution of y. Hope I rephrased that correctly. So that is what we're looking for. So where does it start? As I said, indicated with this line, dotted line, it starts at x equals to 1. How do I know that? Here, just here, we have a coordinate of 1 and 0, right? So that's where this starts. So you can just conclude your answer by just saying when x is greater than 1, right? Why am I using greater not equals to? Is because it's strictly because of this this inequality sign. It's just saying greater. So if it had an equals to, then I was going to put an equals to, but because it just said greater, I'm just going to use greater. So when x is greater than 1, of which we can see from this from these lines that I just did, this, right? When x is greater than 1, we have y value that is positive here, we also have y value that is positive here. So we're having both positive y values giving us a positive solution of y. So this is going to be your final answer for this question. Okay, so 5.4.2 says that when you have g of x being less than or equals to -1, so what is the solution of x when that happens, right? So as I said, when you see g of x, they're talking of y values, right? So you look at the y values, the behavior of y values, where in the graph where you have your y values being less or equals to -1, right? So because we're looking at this g of x, right, and the negative y values of this g of x starts here, right? So it's negative, 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 going down, right? But we know very well that this graph doesn't touch this this y-axis, right? Why? Because it's an inverse, and there's a, remember that we're having an exponential equation. Normal exponential equation is ab to the power of x plus q, right? Which this is an asymptote, right? For this one, it's a horizontal asymptote for this f of x. So, but because we are having y is equals to log of x, right, like this, so meaning that this same horizontal asymptote becomes vertical in this case, so it moves like this, it goes down like this. So this graph of g won't touch this asymptote, right? So this asymptote is at y is equals to 0, right? Yes, it's at y is equals to, sorry, it's at x is equals to 0. So x is equals to 0 at this point, right? Yes, because this is a y-axis, so x is 0 at the y-axis, right? So it's not really touching the y-axis, right? So how we can do this, we will say, we can easily say g of x less than or equals to -1, and just put the equation of the g of x, which is log base 2x less than or equals to -1, right? And then you just find the value of x. So you can do that by saying, so this 2 here is going to be the power, so it's going to be x is equals to, it's less than or equals to 2 to the power of -1, which is x being less than or equals to 1 over 2, right? So this is the first solution that you have here of when g of x is less than or equals to -1. But we also know that it won't touch the y-intercept, right, where x is equals to 0 I indicated. So your final answer can simply be this solution here of but you have to write it as when x lies between your 0, right? Removing this equal sign because your graph will not touch the 0, and equals to 1 over 2, like that, right? So this is going to be your solution for this problem, where the graph will not touch the y-axis when x is equals to 0, and you will get your -1 solution at x is equals to 1 over 2. So this is the solution for this problem here. When x lies between 0 and half, you will get a solution of y which is less than 1. Okay, so now we're going to do 5.5, which says that if h of x is equals to f of minus x, calculate the value of x for which f of x minus h of x is equals to 15 over 4, right? So let's first find h of x. So we know f of x is equals to k to the power of x, of which we found k to be equals to 2 in the previous questions. So f of x is equal to 2 to the power of k, right? So to find h of x, we can say h of x is equals to, because it's equals to f of negative x, so where we see, sorry, just to indicate here that this is x and not k. So where we see f x, we're going to put minus x, right? So it's going to be equals to 2 to the power of minus x. So this is the equation of h of x. So we have the equation of h of x, we have the equation of f of x. So we're going to say f of x minus h of x is equals to 15 over 4, right? So f of x is equals to 2 to the power of x minus h of x is equal to 2 to the power of minus x, right, equals to 15 over 4. So what you're going to do here is we want to calculate the value of x, right, for which this happens. For us to do that, we need to we can use the value of k. We will say 2 to the power of x minus 1 over 2 to the power of x is equals to 15 over 4. So to solve for this value of x, we can say let 2 to the power of x be equals to k, right? So when we see 2 to the power of x, we're going to put k, so it's going to be k minus 1 over k is equals to 15 over 4. And then we can multiply by k all sides to remove this k at the bottom. So multiply by k, multiply by k, multiply by k. And then we will have k squared minus 1 is equals to 15 over 4k, right? So you transpose this k to the other side, we'll have k squared minus 15 over 4k minus 1 equals to 0, right? So what we will have is this. So we'll have k squared minus 15 over 4k minus 1 equals to 0, right? And we can remove the denominator of 4 by multiplying it, right? So you're going to multiply by 4, multiply by 4, multiply by 4, multiply by 4, and we'll have 4k squared minus 15k minus 4 equals to 0. And then we factorize this expression here equals to 0. So it's going to be 4k and k here, and we can put 4 here. When you multiply these 4 and 4, sorry, you're going to get 16, but we know that another factor of 1 multiplied by k is going to give us 15, right? So we can say negative here and positive there, right? So now we have 4k plus 1 being equals to 0, or k minus 4 equals to 0. So we transpose the 1 to the other side. We have 4k is equals to minus 1, k is equals to 4, and divide by 4 both sides. So you have k being equals to minus 1 over 4. So yeah, remember that remember we said 2 to the power of x equals to k. So we can replace that now by saying 2 to the power of x equals to minus 1 over 4. 2 to the power of x equals to 4, right? So here we can change this into 2 to the power of 2, right? And we can write 2 to the power of x being equals to minus 2 to the power of minus 2, right? So the reason why this will not have a solution of x is because of this negative here. The bases are not the same because of that negative, so hence this one has no solution. But we're going to continue from here. So we're having 2 to the power of x equals to 4, which you will have 2 to the power of x equals to 2 to the power of 2. So therefore x is equals to 2. So that is the solution of x for this problem here. X is equals to 2. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.